This is our final project to design a simple MIPS processor to implement the RC5. In this video, we will use 3 different test cases.
The first case is DIN and UKR zeros. In our design, we have 2 different control modes. When we set SW14 as 0, it is continuous clock cycle mode. And when we to 0, it is continuous clock cycle mode. And when we push it to high, it will go on single clock cycle mode. Now, let's push switch 14 to high. In that case, the 7-segment display will show us the current PC. Now, let's push the switch 14 to high and let's clear it. And whenever we press the button BTND, the processor will execute one more instruction, as we can see here.
Now let's reset and push the switch back to the continuous clock cycle. We can see that the PC stops at 3F. It shows that our round K generation is finished, and all the values of our round K are stored in the first 26 address of our data memory. Now let's first do the encode. We press the button BTNR to do the encode. It shows that PC stops at A4, and the encode stored at the last 2 address of the data memory. Oh, sorry. This is the first 32 bits, the last 32 bits. We can check that it's the same. And then we clear it and do the decode process. And we can see that it's the first 32 bits, the last 32 bits. Haha, it's correct. And that's all for test 1.
Now let's move on to the test case 2. I already generate all the bits for all the I already generate all the bits file for the 3 test case. Now let's bring the second test case into the board. It's already brought in. Let's check the initial value. This is the initial DIN input, and let's do the encode first. This is the output for the encode. We can check it against the correct value. They're exactly the same. And then let's clear it and do the decode. This is the result for decode. It is exactly the same. Okay, that's all for test case 2. Let's move on to test case 3.
We have the test case 3.
Let's put it in.
And we clear it. We can see that the last 2 digits of data memory first is the input, our input, and then we do the encode, and the encode the first 32 bits of our encode, and the last 32 bits of our encode. It's the same. And then we clear it and do the decode, and the first 32 bits and the last 32 bits of our decode output. That's all for our 3 test cases.
It seems all things are works fine. Thank you.
Yeah, thank you.